everyone, my name is John Green and welcome to Math Crash Course. I'm kidding, I'm not John Green, but I'm going to be teaching you math today. So we're going to be talking about how to integrate trigonometric functions to the square, specifically the sine and the cosine, which are pretty similar between each other. There's just one tiny detail that's going to change about each one of them, so we're going to have to find out. Okay, so to start, we have the sine square of x dx, and we're going to try to integrate it. So what we're going to do first is we're going to rewrite this as 1 minus cosine of 2x to the squared over 2 dx. Now what we're going to have to do is to separate it into two parts. So this is going to be the integral of 1/2 dx minus 1/2, which we are taking out of the integral of cosine of 2x dx. So in order to further integrate this part, we're going to have to get a u and a du. Our u is going to be equal to 2x, and our du is going to be equal to 2 dx. So our dx is equal to 1/2 of du. Now that we have this information, we know that the integral of both of these parts is going to be equal to 1/2 of x. Here, since we don't have any x or y, we just have to add it, minus 1/2, which is this part, we just leave it the same, times 1/2 of sine, which is the integral of cosine of 2x plus c. Now we just have to simplify this little part here, which will give us 1/2 of x minus 1/4, which is the multiplication of this with this, of sine of 2x plus c. It's very easy and really not that complicated. Okay, so what we have here now is very like what we just did, but instead of using the sine function, we're using the cosine function also to the square. So the steps to follow here are pretty similar. We're going to start rewriting this as 1 plus cosine of 2x over 2 dx, because it is squared, and so the only thing that changes from before is this sign over here. So just like we did before, we're going to have to separate this into the integral of 1/2 dx plus, this time, 1/2, which we're taking out of the integral of cosine 2x dx. So again, our u is going to be equal to 2x. Our du, therefore, is going to be equal to 2 dx, which gives us a dx equal to 1/2 du. Now to integrate this, we're going to get, just like we did before, 1/2 of x minus, plus 1/2 times 1/2 sine of 2x, which is the integral of cosine, plus c. Now as a result, we're going to get 1/2 of x plus 1/4 sine 2x plus c. So as you can see, it's pretty much the same with what we did in the sine function. The only thing that's going to change here is this plus.
When you need to integrate sine to the cube, you would need a different procedure than when you integrate sine to the square. First of all, we need to split sine to the cube into sine to the square times sine of x dx. Then we can substitute sine to the square to 1 minus cosine of x squared. Why? Because we know this next equation. We know that if you add sine to the square times cosine to the square of x, you would have equal to 1. And then if you substitute sine to the square, you would have 1 minus cosine squared. In this case, it would be 1 minus cosine squared times sine, because it's still there, dx. Then we can split this into two different integrals. Sine of x dx plus negative sine of x and the cosine squared of x dx. First, we will concentrate into this part. Sine of x can be integrated into minus cosine of x, simple, plus c. But how can you integrate this part? First of all, we need to establish u as cosine of x. Having u as cosine of x as u, you would know that du is equal to minus sine of x times dx. So this equation could be substituted into u squared times du. So integrating that, you would have minus cosine of x plus u cubic over 3 plus c. That would be in terms of u. But then you need to substitute into minus cosine of x plus cosine of x to the cube plus c over 3. This part, I'm sorry, I forgot to write it. To sine to the cube, cosine to the cube have the same procedure but have a different result. Cosine to the cube first need to be split into cosine of x times the cosine of x to the square dx. Then you know that you can substitute cosine to the square of x into 1 minus sine of x to the square. This because of the same rule that applies, that when you add sine to the square of x plus cosine to the square of x would be equal to 1. And if you substitute cosine to the square, it would give 1 minus sine of x to the square. And in this case, that same part needs to be multiplied into cosine of x dx. Knowing this, we can proceed with the integral, splitting it into two different parts, with cosine of x times dx minus cosine of x times the sine of x to the square dx. In this second part, you know that u would be equal to sine of x, and du would be equal to cosine of x dx. Knowing that, you can simplify cosine of x times the sine of x to u to the square du. And proceeding with the other part, the integral of cosine of x times dx would be equal to sine of x. So it would be a subtraction between these two parts. Later, you know that it would be sine of x minus u to the cube over 3 plus c by the integral of u to the square du. Substituting u with the real u, which is sine of x, the result would give us sine of x minus sine to the cube of x over 3 plus c.
Hi, I'm Roberto, and I'm going to explain how to integrate tangent square. So, since we know that tangent square is equal to secant square minus 1, we're going to substitute on tangent square. Now we're going to split it. And we're going to integrate. So the integral of secant square is tangent, and the integral of 1 is x plus the constant. And that's it.
Okay, so now we're going to try to integrate cotangent squared of x, knowing that the cotangent squared of x plus 1 is equal to the cosecant squared of x. So that way we know the cotangent squared of x is equal to cosecant squared of x minus 1. So we substitute it right here. Cosine squared of x minus 1 with dx. That way we just have to separate the cosecant squared of x dx minus the integral of dx. And we know that the integral of cosecant squared of x is equal to minus cotangent x, and the integral of dx is just plain x plus c. And that's it. It's pretty simple. Okay, so now we just want to make a quick review of all the identities. So first we have that sine square s of x plus cosine squared of x, it's equal to 1. And we learned that we want to use it when we have odd exponents. So then we have sine squared of x is equal to 1 minus cosine 2x over 2, and we learned that we want to use that when they're even exponents. And cosine squared of x is equal to 1 plus cosine 2 of x over 2, and we also want to use it when they're even exponents. Also, we learned that tangent squared of x, it's plus 1, it's equal to secant squared of x, and cotangent squared of x plus 1, it's equal to cosecant squared of x. And that's it.